Boys and girls, Mrs. Lane here, and we are on lesson 27, Measures of Center and Variability. And to be honest with you, this is one of my favorite chapters. It has to do with mean, median, and mode. And I know we've already covered some of that a little bit, so I think you are going to enjoy this lesson as well. If you are in the 2020 version of the instruction book, we are on page 282 and 283. And if you are in the 217 version, it's page 272 and 273. So let's go ahead and start with the question at the top in the tan box. Students in band, chorus, and strings classes collected donations for a fundraiser concert to raise money for the music program. These line plots show the results of asking 10 students from each class how much money they collected. So if we take a look at these line plots, you can see, like, here's the band, and each one of these X's represents a student. So an X on the 40 means one student collected $40. And if you look at the band, they had a lot of kids collect how much? A lot of kids collected $10. And it's the same with the chorus and same with the strings. Each X represents a student, and then it tells us how much money they collected. So let's look at point A. Between what numbers are the most common responses for each group of students? So if we start with the band, and we look at the band and we say, between what numbers were most of the responses? Well, when I look at this, I can clearly see that most of our responses are happening between 10 and 20. So I'm going to write that down, 10 and 20. Let's take a look at the chorus. Where are most of our responses occurring? Well, I've got a 1, a 2, a 4, a 2, and a 1. Looks like to me that most of our responses are in between 10 and 30. Wouldn't you agree? Let's write that down. And finally, strings. Where are most of our responses in the strings? And I look over here, I would say that most of the responses are on the heavier side, on the larger amounts. And so I'm going to say most of our responses are between 40 and 60. All right, moving on to B. It says, based on the line plots, which class raised the most money? Explain. If you're just going to glance at this, which group would you say raised the most money? I hope you said strings, because the strings is correct, because most of the data points are between 40 and 60. So let's write strings raise the most money. Because most of the data points are between 40 and 60. All right, moving on to our next question. Based on the line plots, which class likely raised the least amount of money? Now, when you look at the band, the chorus, and the strings, who do you think raised the least amount of money? To me, I would definitely say it's the band, because most of the data points are where? Most of the data points are at 10. And so most of the data points are on the lowest value. So I'm going to say the group that raised the least was the band. The band raised the least. Because most of their data points are at 10. All right, we're going to go on to D. Do you think these graphs would look different if 10 different students were surveyed from each class? Explain. What do you guys think? If we took another sampling of 10 different students, would we get different looking graphs? And I'd say yes. You expect varying answers when asking statistical questions. Perfect. Let's go ahead and move on to page 283. Okay, here we are on page 283 or 273, depending on which instruction book you have. And it says at the top of the page, on the previous page, you looked at the shape of each line plot to think about what the data mean. You observed that the data for band were clustered around the lesser values, and the data for strings was clustered around the greater values. A cluster of data is a group of data points that crowd near each other. And that makes perfect sense. If you have a cluster of people, you've got a bunch of people gathered together. If you've got a cluster of data, you've got a group of data points that are gathered together. So here are some other terms that you can use to describe the shape of data points on a graph. So this is some more vocabulary words. We just want to think about what they mean. And the first one says, a graph is skewed left when most of the data points are clustered near the greater values. I'm going to read that again because it seems a little bit backwards. A graph is skewed left when most of the data points are clustered near the greater values. So if we look at this graph right here, most of the data points on this graph are clustered near the greater values. So this graph would be skewed left. Does that make sense? It's skewed left when most of the points are at the greater values. Let's look at B. A graph is skewed right when most of the data points are clustered near the lesser values. So let's look. Which one of these graphs has most of the data points clustered near the lesser values? I hope you chose this one because this is the graph that is skewed right. Symmetrical. Symmetrical graphs have the same shape on either side of a middle point. And if you look at this graph in the middle, we can see it's symmetrical because here's our middle point, there's our high peak. And at 20, we have 4 data points. Then you go to either side of 20, to the 10, they have 2, and to the 30, they have 2. And to the 0, they have 1, and to the 40, they have 1. So it's symmetrical. It's the same on both sides. D, a peak forms when many data points are at one value. And you can see that right here. Here's our peak. Our peak's at 20. And finally, an outlier. An outlier is a data point far away from other data points. It doesn't quite fit with the rest of the data points. And we've talked about, we've had an outlier as one of our vocabulary words in reading. And it's the same thing here. It's a data point that's far away. It's not part of the group. It's not part of the cluster. So read through those again. Make sure you have a firm and a solid understanding. And then we'll move on to the reflect. Number 1. Can an outlier value be part of a cluster of values? Explain. What do you guys think? Can the outlier be part of the cluster? No. Because by its very definition, an outlier is a point far away from the other points. All right, boys and girls, awesome work today. Go ahead and do your PPS pages for me, and I'll see you tomorrow. Bye.